In this question, we're given some information about a Venn diagram in set notation. And the first line given to us is the universal set. Now this universal set represents all of the numbers that go inside the rectangle. Now in the universal set, some of the numbers may belong in set A, some may belong in set B, and some may not be in either, and so those numbers will be outside of the two circles, but still within the rectangle. But first let's start with set A and set B. In set A, we have 1, 5, 6, 8, and 9, and in set B, we have 2, 6, and 9. And so let's start by filling in the intersection between A and B, and the intersection represents the numbers that fall within set A and within set B. And so on our Venn diagram, the intersection between A and B is represented by the shaded overlap. Now let's look through set A and set B to see which numbers they have in common. And the first number we can see is number 6. Number 6 belongs in set A and set B, and so this will fall in the intersection. Now if we continue looking through set A and set B, we'll see that number 9 also falls within both sets. And so we can add number 9 to our intersection. Now we've seen that 6 and 9 are the only two numbers that fall within set A and set B. Now let's complete the diagram for set A. Now we have the numbers 1, 5 and 8 left in set A, and these are only in set A and not set B. And so we can add this to our Venn diagram by placing the numbers 1, 5 and 8 anywhere in the circle for set A outside of the intersection. We can now do the same thing for set B. The only number we have left in set B is the number 2. Now number 2 belongs to set B, but not set A. And so we can add number 2 to our Venn diagram by putting it anywhere in the circle for B outside of the intersection. But now we haven't quite finished our diagram. Now let's take a look at our universal sets. We have 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now from the universal set, let's highlight the numbers that we've already added to our Venn diagram. Now from the universal sets, we can see that the numbers 1, 2, 5, 6, 8 and 9 have already been added to our Venn diagram because these numbers belong in either set A or set B or both. But we still have the numbers 3, 4 and 7 in our universal sets that we haven't written in our Venn diagram. Now since the numbers 3, 4 and 7 are within the universal sets but do not belong in either A or B, we can write these within the rectangle but outside of the circles for A and B. And so we've now correctly completed our Venn diagram to represent the information given to us in the question. Now we're told that a number is chosen at random from the universal sets, and in part B, we need to find the probability that this number is in the set A and B. Now this symbol that was circled represents the intersection of set A and set B, and so it represents the information that's in both set A and set B. And the numbers in set A and set B are 6 and 9. And so in our set of data, there are two numbers which fall within set A and set B. Now in our set of data, there are 9 numbers in total. And so we can therefore say that the probability that the number is in the set A and B is equal to 2 out of the total of 9. And so we've found that the probability that the number is in set A and B is equal to 2 out of 9. Which we've written down in our answer box. Now this question is worth 5 marks. We get the first mark for getting the intersection correct in our Venn diagram, and for having only the numbers 6 and 9 in the overlap between A and B. We get the second mark for placing 1, 5 and 8 in set A, but not set B, and for placing the number 2 in set B, but not set A. And we get the third mark for writing the numbers 3, 4 and 7 within our rectangle, but outside of set A and set B. We get the fourth mark in part B for identifying that there are two numbers that fall within both set A and set B. And we get the fifth and final mark for using this and the fact that there are 9 numbers in total in order to find that the probability that the number falls within both set A and set B is 2 out of 9. Allowing us to get the full 5 marks needed in this question.